Welcome back to AP Chemistry Summary Review, Session 5. We got one more to go after this one, and today we're going to hit a big one. This is chemical naming. It's something that a lot of people tend to be kind of scared of, and they remember trying to learn how to do that in regular chemistry in high school, and it was kind of intimidating, or maybe they didn't understand. Can be rather difficult, and now, or they just, you've forgotten things, and you see a chemical name now, and oh wait, I don't remember what that was. I don't remember how to deal with this. So this is, for me, a skill set, okay? If you're gonna work in an office, then maybe knowing how to properly use, say, Microsoft Publisher or Excel or some other computer program, that might be a skill set for that job. Knowing how to talk clearly on a phone or deal with customers, that's a skill set. And so for chemistry, knowing how to name is a skill set. It's something that's really going to help you as we go through chemistry. After this first test that I give you, I'm not going to constantly be asking you, what's CO2? Or how do you, what acid is hypochlorous acid? What's the formula for it? I'm not going to ask you those questions specifically, but if you don't know how to name, it's really going to hold you back. Because if I say, use hypochlorous acid for this, or it comes up in a test question, and you don't know what hypochlorous acid is, you're going to have a very difficult time answering that question. Okay, so it's a skill set. So I'm going to give you the information today for how to name and kind of systematize it for you. And then, because it is a skill, what you really need to do is go and practice. I have given you pretty lengthy practice sheets for this one, naming worksheet. There's also a lot more practice you can find online for free with multiple different websites. If you need more help, please contact me, and I'd be happy to give you some more sites to use or answer your questions. But make sure that you have this skill. What skill? The skill of being able to look at a chemical formula, C2H3O2, and tell me what it is, name it. Or to look at a name, like sulfuric acid, like hydrogen bicarbonate, and to tell me what that is. Okay, we're not doing organic naming, which is things like, ethyl dimethyl hexane or something. We're not doing that. Typically, this is called binary, the binary naming system, which means that there's only two different types of atoms. There could be more than two atoms, but only two different types, only two different elements. I don't really like to call it that because when you throw in polyatomic ions, it's no longer just two, but still that's what we're doing. It's sometimes also called inorganic naming. All right, now classically this can present some problems, so I gave you some memes here for the day. People kind of struggle with this one, and it can get, we're not doing this complicated, but really complicated here, so let's agree to dispense with the rules of nomenclature and call it X. Good old X. But anyway, so here we go. When I teach naming, I like to break it up into 5 categories. You have type 1, type 2, type 3, acids, and oxyacids, and then teach you a little system for naming those types. So if you can figure out, if you look at this compound or look at this name, and you can figure out if it's type 1, type 2, type 3, an acid or an oxyacid, then you just kind of plug in the steps and you should be able to name it. Okay, being able to identify them is a big deal. I did give you a naming flowchart. Those are very helpful if you like to use those. I have one here in this PowerPoint, and I have another one that actually was mine that I wrote out that you have a link to online. Okay, so type 1, okay? Type 1 is one of the simplest to name. This is when you know the charge of the metal. Wait a minute. Which metals do you know the charge of? Well, for this class, anything in group 1, okay, that would be this red column here, well, and hydrogen. Anything really in group 2, group 1 is a charge of +1, group 2 is a charge of +2. That could also include silver, you're supposed to know that has a charge of +1, very good. And aluminum, which has a charge of +3, okay? Good, so you need to know those charges. Those are all metals. We know the charge. There are some others that some different curriculums might throw in there as type 1 that we know the charge of. I'm just going to leave it those for right now. So if you look at your compound, the first element is a metal, and it's one of those metals I just pointed out that you know the charge of, you have a type 1 compound. So all you got to do to name a type 1 is state the name of that metal. So if you have magnesium, you look at this, okay, that's a metal. How do I know it's a metal? Because it's over here, over there on the table, on that left side of the staircase. So it's a metal, and then it's in group 2A, right here. So therefore we know the charge, type 1, so just give the name. Okay, you'd say magnesium, write it out. And then for the non-metal, give the name plus an IDE, an IDE ending. So this is oxygen. We're going to change that to oxide. That's all you have to do. This is magnesium oxide. Okay, here we have sodium chloride, which would be Na, because that has a charge of +1, Cl, because that has a charge of -1. Okay, could be potassium, sulfide, lithium chloride, rubidium fluoride, something like that. So they just have an "ide" ending. Name the metal first. The whole key to naming these, recognize that you have a metal and that you know the charge of that metal. All right, that's type 1. Oh, wait a minute. Did you notice something? I forgot to mention. So for the non-metal, it could also be a polyatomic ion. Oh, no. You know what you're going to have to do, right? Yeah. You're going to have to memorize these polyatomic ions. So there's a lot of them, but I do want you to memorize them. People try to skip this one every year, and I think I can get away without me. You cannot, okay? You're going to hit that test, and you're going to be seeing ClO2, and you're going to spend 5 minutes trying to remember if that's hypochlorite or chlorite or chlorate or carbonate, and you don't remember. That's a problem. You need to know these off the top of your head. So I gave you a list here. I did cross out a few of these that, to me, are not commonly used, so I didn't want to make you memorize those, but please know all of these. When I say memorize it, what do I mean? I mean, if you see NH4, you can tell me that's ammonium. If you see ammonium, you know that's NH4 plus. Hypochlorite, ClO minus, okay? OH minus, hydroxide. So if I give you one, you can tell me the other one, just like that. And for some of you, this is going to be a breeze, not very difficult at all. For some of you, if you have a harder time memorizing, or for me, I don't struggle with memorizing a lot, but I do struggle with numbers and like the charges. So I'm like, I think that's permanganate, but I can't remember if it's -1 or -2, that kind of thing. So they can be a little tricky. Give yourself flashcards, whatever you need to do to memorize these, just make sure you have them memorized, okay? Because what can happen with a type 1 is you have a metal. So let's say we have that magnesium again. But instead of just having one nonmetal here, you have a polyatomic ion. So maybe this is Mg. We'll just use hypochlorite since I mentioned it. ClO, and then actually we would need 2 of these. So this is your compound, right? So Mg, okay, metal, we know the charge, type 1, magnesium, and then all you have to do is just name the polyatomic. So don't change it to "ide." We know what polyatomics are, just leave it alone. This would be magnesium hypochlorite, okay? Don't forget, just a little side note here, if you have parentheses around something, and then a 2 outside, that means I have 2 of everything inside. So I have 1 magnesium, and there's 1 hypochlorite, 2 hypochlorites that are bonded to 1 magnesium. Okay, so it might look something like this, like here's your magnesium in the middle, and then you have a hypochlorite over here, and a hypochlorite over here. So it's 1 big molecule with a magnesium and 2 hypochlorites attached to it. Okay, that's what that 2 means. All right. So make sure you memorize these. There's a couple key ones that people tend to mess up. A couple new ones on here from last year, if you had to memorize these last year, but not very many. Most of these should be very common for you all. Right, just a couple notes here. But right here, we have ClO or OCl. Don't do that. Just do this one, okay? That's usually what you see. Yeah. And typically the first one is the one you really should focus on if there's like 2 of them here. All right. If you have any questions, please feel free to ask, okay? Okay, type 2. This is when the metal is not known. The metal has a variable or unknown charge. So that is going to typically be a transition metal. It could be anything really over here to the staircase, except for silver because you know the charge of that, and aluminum because you know the charge of that. Could also, I guess, be something down here. We don't often name those, but usually something in this region. Okay, so if you recognize that your first element is a metal, and you don't know the charge, then name it this way. And so type 2 is just like type 1, except for the fact that you are going to add Roman numerals. So use Roman numerals in parentheses to indicate the charge of the metal. What do the parentheses indicate? The charge of the metal. You say, Miss, I can read. I know you can read, but this is really easy to confuse. And 9 times out of 10, if you're going to mess up naming this, it's because you didn't put the charge, you put the number of atoms. So like an example would be lead 2 oxide. So this would be PbO. Okay, so if you're looking at this compound and you want to name it, how do you name it? We'll just name the metal. That's Pb is lead. I know it looks like peanut butter, but it's lead. So lead, and then when you get to the ending, it would be oxide. Okay, oxygen, oxide. So you keep that "ide" ending, but in the middle you're going to need to give the Roman numerals, and this is Roman numeral 2. Okay, don't forget Roman numerals are like I, and then you get into IV, V, VI. That's probably as high as you need to go. If you know that many, you'll be fine. These don't go up that high, okay? So PbO, this 2 tells me the charge of the lead. I do not have 2 leads. It's not Pb2O. Each lead has a charge of +2. So if you look at the charges here, we know that oxygen is -2. And in order for this compound to equal 0, that means that lead has to have a charge of +2. Okay, so that tells me the charge. And the reason they're telling you the charge is because that's what I don't know. These metals are metals of an unknown charge. So in order to properly work with them, I need to know that charge. And that's why we name them this way. We tell you the charge because you don't know, all right? So that's type 2. Let me just give you... And these, again, the ending can also be a polyatomic. So let me give you an example of that. Let's say... Okay, so what if you had something like this, MnOH2? In order to name it, you do need to know what the charge is. You say, wait a minute, Miss, how do I know the charge when you just told me I don't know the charge? Okay, you don't know it like you don't have it memorized, but you can figure it out. How do you figure it out? Look at the ending. You're gonna know that charge. If it's a non-metal, you're gonna know the charge of it. If it's a polyatomic ion, you memorize the charge of it. Okay, so OH is a polyatomic, it's hydroxide, and the charge, I have it memorized, is -1. And that's all the information I need to figure this out. If that's -1, there's 2, so this is -2. To get the entire compound to equal 0, remember that compounds equal 0, you're going to need to make this a +2. Okay, because there's only 1. So there's 2 here, there's only 1. So this has to be +2. Okay, +2 minus 2, 0. There's only 1, so that is in fact a +2. So in order to name this, okay, and this is gonna, it's too long to write out with my mouse that is not good at writing. So it would be Mn is manganese, manganese in parentheses 2, because that is the charge of manganese, and then write this word hydroxide. Okay, so just plug in the polyatomic. If it's not a polyatomic, then change the ending to "ide." Okay, awesome. All right, that's 2 down, 3 more to go. Type 3, this one I like. I just think it's a little easier to do and you don't have to worry about as many endings on it, so I like it better. These are covalents. So both of the items in this molecule are gonna come from over here. Okay, there will be no metals. That is the dead giveaway that you have a type 3. There's no metals. So if you look at it, both are non-metals. Go to type 3. How do we name these? You name them using all these prefixes that I put everywhere. So the Greek prefixes, okay, mono, di, tri, tetra, penta, hexa, hepta, octa, nonadeca, dodeca, if you want to go that far. Okay? By the way, when you put them together, if you're ever wondering, put the least electronegative element first. You probably won't run into this in this chapter, but that means, so electronegative goes this way, if you remember that. So the element, the farthest, the least would be this way. Okay, so if you have a P and an F together, put the P first and then the F. If you have N and Cl, put the N first and then the Cl. Whichever one is more that way goes first. Okay, name them using Greek prefixes to tell the number of atoms, not the charge. We know the charge. You don't need to tell me the charge. I know that already. And actually, they're covalent, so they're not, in this instance, they're sharing electrons, right? They're not acting like charged elements, so don't worry about the charge. What I don't know is how many, so that's what you have to tell me. That's why we use Greek prefixes. So, for instance, carbon dioxide, CO2, there's 1 carbon, there's 2 oxygens, so it's carbon, di for 2, oxide. You do still have the "ide" ending. Most naming compounds have an "ide" ending, but we use di for 2. The only little exception here, and actually this is an example of it, is in the beginning, this carbon. Why isn't it monocarbon? Don't use mono, on the first element. If you don't put it there, then we're just going to assume it's there. Okay, so just don't say monocarbon dioxide, just say carbon dioxide. If it was on the second one, so like classic example is CO, carbon monoxide. You can't just say carbon oxide. You do have to put the mono in there. So only use the mono on the second one. Reason being, if you just said carbon oxide, I'd probably think it was a type 1. So I need something to indicate it's a type 2, so go ahead and put the mono on the second. Don't put it on the first. It's just a waste of words and effort, I suppose. If you don't say it, we assume there's only 1. All right, so let me give another, maybe like... not even sure this is a legit compound, but NBr3. So nitrogen's a nonmetal, bromine's a nonmetal. So this would be nitrogen. Don't use mono, it's the first one. And then 3 tribromide. Okay, nitrogen tribromide, things like that. Okay, that's type 3. The last ones are the acids. I like these. I like acids because they're just kind of fun to say, right? Everyone's like, acid. Ooh, scary. Whether that acid is actually scary or not. You put the word acid on it, people think it's scary. It's great fun. All right, and some of them are. Don't go playing with acids, but anyway, we'll use some later this year, okay? For an acid, and when I just called an acid, for naming specifically, for lack of a better name, an acid for me is something that does not contain oxygen because those are included in the oxyacids. Really, an oxyacid is a subcategory of acid because acid can refer to all of them. Anyway, for this category, you're going to have hydrogen first. That is how you know that this is an acid. So if you're looking at a compound and you have HF, okay, my H comes first. Aha, that means it's an acid. That's how you know it. Technically, I put this. Technically, it must be aqueous in order to be an acid. Don't worry about that for this chapter, but when you're writing out equations later, that might come important. So like technically, HF, if this was a solid, this would be hydrogen fluoride. You name it like that, but if it's aqueous, so if that's an AQ, technically if it's aqueous, then that would be an acid. It's hydrofluoric acid. Okay, these are fun to name, so they don't have oxygen. So the first element is hydrogen. The second element is going to be something else, but not oxygen. And you name them like this: hydroblankic acid. Put the name of the element in the blank. So if it's HCl, really common one here. H first, no oxygen. This is chlorine, so put that in the blank. Hydrochloric acid. HF, hydrofluoric acid. Okay, these don't generally have polyatomics. The only polyatomic that will work here, because it needs to not have oxygen, and most polyatomics have oxygen, is HCN. Okay, this is cyanide. There's no oxygen, so we name it this way. It'd be hydrocyanic acid. That's really the only one that's going to form with a polyatomic ion. Okay, so fill in the blank. All right, last category, oxyacids. These are probably the hardest to name in my personal opinion. So I gave you a little chemistry animal friend to maybe make this easier for you. Our good old friend Mighty Mouse, okay? So in an oxyacid, oxygen plus acid, you're going to have an H first, and followed by something else, typically a polyatomic ion, as a matter of fact, always a polyatomic ion. And in that polyatomic, you're going to have oxygen. So if you have a hydrogen followed by an oxygen, that is an oxyacid. Be careful, because some things, like if you have C6H12O6, like, oh, I have a hydrogen and I have an oxygen. It's an oxyacid. No, it's not, because hydrogen's not first. It is specific in chemistry which one you put first. So if hydrogen's not first, that is not an acid. Okay? Typically we'll contain a polyatomic, and then we use this little thing to name them. So my little silly phrase is Mighty Mouse ate something icky. I know that sounds really weird, but it will help you remember, okay? So, because you gotta change the ending. If you have an ite ending, you're gonna change that to us. So you see it here, Mighty Mouse. Ite becomes us. And then if you have an ate ending, you're gonna change it to ick. Okay, so ate something icky. Ate changes to ick. And there's a little drawing of them. So that helps you remember. Here's how we'd use this. If you have HClO, I have an H first, followed by a polyatomic. This is hypochlorite. In order to name the acid, I have to change the ending. This is hypochlorite, so Mighty Mouse. Ite becomes us. It's going to be hypochlorus. And then just put the word acid. You do not need a hydro in front. Okay? Change the ending, put the word acid. That's all you got to do. So let's try this other one. We have H2CO3. Okay, we have an H first, followed by an O. It is an oxyacid. So what is CO3? And this is where you have to have them memorized. If you do not have these memorized, you're not going to be able to name them. CO3 is carbonate, okay? Carbon 8. Mighty Mouse ate something icky. So 8 becomes ick. So carbonate becomes carbonic, and then just put the word acid. So this is carbonic acid, okay? Do not use a hydro. Hydro is only for the regular acids. Okay, that is all 5 types. Sometimes that can be hard to put together in your brain. And when I just can throw any of one of these at you, and you have to be able to name it, you be able to look at that and tell me which type it is. So I did include this chart for you. This is not mine. Found it online. There's actually, oh, this won't clear now. This is not mine. I found this online. You can find other ones if you would like. I put my little flowchart up on our Google Doc if you'd like that one. But they generally start out with a series of questions, and if this helps you think about this, then follow the series of questions. So this one starts with, is there a metal? Yes or no. Okay, if there's not a metal, is the first element hydrogen? Yes or no. Is it a transition? For me, here's the questions I like to ask. Okay, I just put this here. It's a different way of thinking. Some of you might find that easier to follow. For me, I'm going to start out with question number 1. Does it start with a hydrogen? Because if it starts with a hydrogen, you know it's an acid. And then you'd ask yourself, okay, if it's an acid, is there an oxygen? If there is, it's an oxyacid. If it's an oxyacid, use Mighty Mouse ate something icky. If it's a hydrogen and not an oxygen, then use hydroblankic. Okay, so question 1, is there a hydrogen? If there's not a hydrogen, then question 2, I would say, is there a metal? Okay, if there's not a metal, you have a covalent compound. Type 3, use the Greek prefixes. If there is a metal, then you have a third question. So question 1, is there a hydrogen? Question 2, is the first element a metal? Question 3, do you know the charge of that metal? If you do not know the charge of that metal, then it's type 2, and you're going to use the Roman numerals. If you do know the charge of the metal, then it's type 1, and it's just metal, non-metal, ide. Okay, so that's just a brief rundown. I know that was really fast. I give you a lot of practice on this one. Please ask if you have questions and get the extra review that you need, okay? Even the best of us need to go back and review naming, especially after a summer of not doing it. All right, hope that was helpful. I will see you next time for the last review session.